Cobalt bomb, most dangerous bomb in the world. A cobalt bomb is a type of salted bomb, a nuclear weapon designed to produce enhanced amounts of radioactive fallout, intended to contaminate a large area with radioactive material. The concept of a cobalt bomb was originally described in a radio program by physicist La Salle on February 26, 1950. His intent was not to propose that such a weapon be built, but to show that nuclear weapon technology would soon reach the point where it could end human life on Earth, a doomsday device. Such salted weapons were requested by the U.S. Air Force and seriously investigated, but not deployed. Citation needed. In the 1964 edition of the U.S. Department of Defense book The Effects of Nuclear Weapons, a new section titled Radiological Warfare clarified the doomsday device. The Russian Federation has allegedly developed cobalt warheads for use with their Status 6 oceanic multi-purpose system nuclear torpedoes. However, many commentators doubt that this is a real project, and see it as more likely to be a staged leak to intimidate the United States. Amongst other comments on it, Edward Morgeist wrote a paper in which he says that Russian decision-makers would have little confidence that these areas would be in the intended locations, and Russian military experts are cited as saying that robotic torpedoes could have other purposes, such as delivering deep-sea equipment or installing surveillance devices. The Operation Antler Round 1 test by the British at the Tabgee site in the Maralinga Range in Australia on September 14, 1957, tested a bomb using cobalt pellets as a radiochemical tracer for estimating yield. This was considered a failure and the experiment was not repeated. In Russia, the Triple Taiga nuclear salvo test, as part of the preliminary March 1971 Pekora-Alma Canal project, produced relatively high amounts of cobalt-60 from the steel that surrounded the Taiga devices, with this fusion-generated neutron activation product being responsible for about half of the gamma dose. Now 2011. At the test site, this high percentage contribution is largely because the devices did not rely much at all on fission reactions, and thus the quantity of gamma-emitting cesium-137 fallout is therefore comparatively low. Photosynthesizing vegetation exists all around the leg that was formed. A cobalt bomb could be made by placing a quantity of ordinary cobalt metal 59 Co around a thermonuclear bomb. When the bomb explodes, the neutrons produced by the fusion reaction in the secondary stage of the thermonuclear bomb's explosion would transmute the cobalt to the radioactive cobalt-60, which would be vaporized by the explosion. The cobalt would then condense and fall back to Earth with the dust and debris from the explosion, contaminating the ground. The deposited cobalt-60 would have a half-life of 5.27 years, decaying into 69 and emitting two gamma rays with energies of 1.17 and 1.33 megavolt. Hence the overall nuclear equation of the reaction is nickel-60 is a stable isotope and undergoes no further decays after emitting the gamma rays. The 5.27-year half-life of the 60 Co is long enough to allow it to settle out before significant decay has occurred, and to render it impractical to wait in shelters for it to decay, yet short enough that intense radiation is produced. 9. Many isotopes are more radioactive: gold-198, tantalum-182, zinc-65, sodium-24, and many more, but they would decay faster, possibly allowing some population to survive in shelters.